Chapter 11, Section 2, Solving Multi-Step Equations. The objective of this lesson is to learn to solve multi-step equations. Simplifying the equations by, first, multiplying to get rid of fractions. Number 2, use the distributive property, and this should be number 3, which would be combining like terms. Then, isolate the variable. So in example A, we've got 8x plus 6 plus 3x minus 2 equals 37. There are no fractions to get rid of. We don't need to use the distributive property, so we're going to go to step 3, which is combining like terms. I see an 8x and a like term of 3x. Now remember, we include the sign in front of the term. So on the left-hand side, we're going to combine these two. We also have 6 and subtract 2. So we have plus 6 minus 2. Those are like terms. So the 8x and the plus 3x will come out to be 11x. The plus 6 minus 2 will come out to be plus 4. On the right hand side, we have plus 37. Now we want to isolate the variable. The variable is x. We want x all by itself. X is being multiplied and added to. We want to do PEMDAS backward, which means we want to undo the addition first. So undo adding 4 by subtracting 4. I can do that as long as I subtract 4 from the other side. Now we're going to simplify. 4 minus 4, that will cancel out. On the left-hand side, I'll be left with 11x. On the right-hand side, I'll be left with 33. X is being multiplied by 11. To undo multiplication, we're going to use the inverse operation of division. So I'm going to divide the left-hand side by 11 as long as I divide the right-hand side by 11. 11 divided by 11, that will drop out. On the the left-hand side, I'll have x. On the right-hand side, I'll have 3. Now what I can do is I can turn around and test. I can check, does x actually equal 3? I can use the original equation of 8 times x plus 6 plus 3x minus 2 equals 37. But I can substitute 3 in for x. So I would have 8 times 3 plus 6 plus 3 times 3 minus 2 equals 37. 8 times 3 is 24, plus 6 is 30. 3 times 3 is 9. That would be 39 minus 2 is 37. So x does equal 3. Now let's take a look at example B. Example B, there are no fractions to get rid of, but there is the distributive property. The distributive property, we're going to use 4 times x, which will come out to be 4x, and then 4 times 6, which will be 24. However, we're going to bring this subtraction sign down. And then the rest of the equation, plus 7 equals 11. So now 4 times 6 is 24, but remember we're going to subtract that from 4x, bring down the plus 7 equals 11. Now we're going to take a look at some like terms here. On the left-hand side, 4x does not have a like term, but 24 and 7 are like terms. But remember, I'm going to include the sign in front of the term. So it's not just 24, but it's subtract 24 plus 7. Now I'm going to simplify that. A negative 24 plus 7 will come out to be negative 17. Then I'm going to bring down the first term, which is 4x. The last part of the equation equals 11. Now, 4x, I've got multiplication happening to x and subtraction. We're going to undo the subtraction first by adding 17. I can do that as long as I add 17 to the right-hand side. Subtract 17 plus 17. These will drop out. On the right-hand side, I have 11 plus 17 will come out to be 28. I'm going to bring down the equal sign and the 4x. We're getting close to isolating the variable. The last operation that we need to undo is the multiplication. X is being multiplied by 4. So we're going to use the inverse operation of multiplication, which is division. So we'll divide the left-hand side by 4 as long as I divide the right-hand side by 4. 4x divided by 4, that will drop out, and I'll end up with x. I'll have isolated the variable. 28 divided by 4 comes out to be 7. X is 7. In the next example, I have 7/12 equals a negative 3m over 6 minus m over 3 plus 1/4. First, we want to multiply all terms by the least common denominator. So let's take a look at the denominators. The denominators that we have are 12, 6, 3, and 4. What number does 4, 3, 6, and 12 go into evenly? But we want to find the least common denominator. 3, 6, and 12 do not go into 4. 3 goes into 6, however 4 nor 12 go into that evenly. 12. We could use 12 as our least common denominator. 6 goes into 12 twice. 3 goes into 12 4 times. 4 goes into 12 3 times. Now, I'm going to multiply every term by 12. So I'm going to multiply the first term by 12, but I'm going to write 12 as a fraction, 12 over 1. I'm going to multiply this term by 12 over 1. I'm going to multiply this term by 12 over 1 and the last term by 12 over 1. Now let's start to simplify. This 12 can divide out. It goes into 12 goes into 12 once. I'm dividing this denominator by 12 as long as I divide the numerator, this numerator, by 12. Let's take a look here. 6 goes into 6 once. 6 goes into 12 twice. And over here, 3 goes into 3 once. 3 goes into 12 4 times. In the numerator and the denominator, I can simplify. 4 goes into 4 once. 4 goes into 12 3 times. So I'm going to start to simplify the left-hand side. 7 times 1 is 7 over 1. The left-hand side will be 7. When I multiply these terms, I have 2 times 3m, which would be 6m, but remember, I'm subtracting, so I am going to subtract 6m, or negative 6m. I have 4 times m over 1, which would be 4m, but remember, the sign in front is subtraction, so that will be 4m. In the last set here, I've got 3 times 1 in my numerator and 1 times 1 in the denominator, so I'm going to end up with 3. Now, the left-hand side, there are no like terms. Let's take a look at the right-hand side. I've got negative 6m and minus 4m. Those are like terms. I'm going to combine those to a negative 10m. I'm going to bring down the remaining terms of plus 3 and on the left-hand side 7. We want to isolate the variable m. M is being multiplied by a negative 10, but it's also 3 is being added to it, so we're going to do PEMDAS backward. I'm going to undo the addition first by subtracting 3 to the right side. I can do that as long as I subtract 3 from the left side. These 3's will drop out, and on the left side I have 7 minus 3, which comes out to be 4. On the right side, the only remaining term is negative 10m. M is not quite isolated yet. It's being multiplied by a negative 10. So I'm going to use the inverse operation of multiplication, which is division, and I will divide the right-hand side by a negative 10. I can do that as long as I divide the left-hand side by a negative 10. These negative 10s will divide out because one's in the numerator and one's in the denominator. On the right-hand side, I'll be left with m. on the the left-hand side, I'll be left with 2/5. I reduced 4/10 to 2/5. Now remember, it's negative, so my negative sign is going to go in front. In this example, we have 4/5 minus 2p over 5 equals 6/5. Now, our first step is to eliminate the fractions. We need a common denominator, so we're going to look at the denominators of 5, 5, and 5. Well, the common denominator would be 5, so I need to multiply every term by 5 or the fraction 5 over 1. So 4/5 is going to be multiplied by 5 over 1. 2p over 5 is going to be multiplied by 5 over 1. And 6/5 are going to be multiplied by 5 over 1. Now let's simplify. 5 goes into 5 one time, and I can divide that out of the numerator. 5 goes into 5 one time. This 5 goes into 5 one time. This will simplify to 1. This will simplify to 1. And I'm going to end up with 4 times 1, which is 4, over 1. So my first term is going to be 4 minus 1 times 2p over 1 times 1, which is 2p. But remember, it's subtracting. Bring down the equal sign. On the right-hand side, I've got 1 times 6 over 1 times 1. So it'll be 6 over 1, which is equal to 6. Now, take a look at the equation that we have here. This 4 minus 2p equals 6 is the same as these numerators. That is because every single term has the exact same denominator. So we went through a long process of multiplying it by the least common denominator. However, there's a shortcut. If every term has the exact same denominator, we can just eliminate that denominator and work with the numerators. 4 minus 2p equals 6. 4 minus 2p equals 6. Now let's continue to isolate the variable. 2p, p is being multiplied by 2, and we have a 4. We want to get rid of the 4 first. I can do that by subtracting 4 to the left-hand side, as long as I subtract 4 to the right-hand side. These 4's will drop out, and I'm left with negative 2p equals, on the right-hand side, I have 6 minus 4 is 2. P is still being multiplied by a negative 2. I'll undo that with the inverse operation of division. I'm going to divide by a negative 2 as long as I divide the right-hand side by a negative 2. These negative 2's will drop out, and I'll end up with P equals 2 divided by negative 2, which is negative 1.